Task 7 Modeling of the Cylinder Block of a Engine. Lecturer, Li Huachuan. Hello, everyone. In this lesson, we will learn about the modeling of the cylinder block of engine. Through the model animation, we observe that the cylinder block of engine is the basis of the assembly of various parts of the engine, ensure the specification accuracy of key components. The cylinder block and cylinder head form a combustion chamber, which bears high temperature and high pressure. As a mechanical design engineer, you must first be familiar with the functions and working conditions of parts before you can carry out precise structural design. Precision, diligence, standardization, and innovation are essential professional qualities for engineers. So how is the cylinder model built? Through blueprint analysis, we divide the cylinder block into the following parts. 1. Lower cylinder block. 2. Upper cylinder block. 3. Ramp. 4. Floor. 5. Side platform. For each component, our proposed modeling approach is as follows. 1. Lower cylinder block, constructed using sketch and revolve. 2. Upper cylinder block, constructed using cylinder, extrude and array. 3. Floor, constructed using sketch and rib plate. 4. Ramp, constructed using sketch, extrude and edge blend. We will divide the cylinder block of an engine into two parts for explanation. In this lesson, we will study the first part first. Next, we will open the UG software and go through the modeling process of reading drawings, drawing, correcting errors, refining to master the method of the modeling of the cylinder block of engine. Please pay attention to cultivating the professional qualities of precision, diligence, standardization, and innovation. Click on New. The name of the model. Engine box. Folder. Locate the destination folder where the model is saved. Double-click OK. Click on the resource bar. Web browser. Click on the left button to drag the engine box drawing into the resource bar. Click on Menu. Preferences. Sketch. Set preferences. Cancel. Continuous auto dimensioning. Click on Customize. Click on Menu. Insert. Sketch in task environment. Drag it to the ribbon. Click OK. We first need to draw the main structure of the engine box. Select the origin of the coordinate system. Draw diagonal lines. Start by drawing the general shape of the outline. Click on the line L. Trim. Click on Rapid Dimension. This section is half the size of 40, which is 20. Simultaneously, the angle between diagonal lines is 6 degrees on both sides. One side is 3 degrees. The two slashes are parallel. Three degrees. The two lines are parallel. This section of the line has a radius of 31. This section of the line has a radius of 52 plus wall thickness. The wall thickness on both sides is twice 3, which is 6. 52 plus 6. The diameter of this section is 58. So the radius is half of 58. We continue to mark the axial dimensions. 20. Grasp the two lines. 40. You can grab two endpoints. 16. Select the line. 16. The total length is 135. The main structure is complete. Click on Revolve. Select the sketch. Click on Specify Vector. Select the rotary axis. OK. We go on to draw the cylindrical part. It is composed of two cylinder sections, 64 and 60. Click on the feature ribbon. Design feature drop-down. Check cylinder. Click on cylinder. Vector. The system defaults to the vertical axis direction. Click on Specify Point. Click on the dialog box. We need to judge the coordinates of the center of the bottom circle of the top surface of phi 64. The coordinate system point is now on the left end face. So the coordinates of this point here are in the height direction. That is, in the z-axis direction. Its distance should be 100. Also note that the top 1 mm distance is added. So it should be 101 in the z-axis direction. At the same time, in the horizontal axis direction, its distance should be 103. Note that the horizontal axis direction is now the x direction. XC is 103. Enter. Click on OK. Vector direction is reversed. Its diameter is 64. What is the height of the 64 cylinder? Pay attention. The distance between each disc is 4.5. 12,345. There are 5 parts in total. At the same time, add the thickness of the spacing of 1.7 plus the highest. Offset distance of 1 mm. So the height of the 64 column should be 4.5 by 5 plus 1.7 plus 1. OK. There is a section of 60 cylinder below the 64 cylinder. Click on cylinder. Click on Specify Point. Select the center of the bottom of the cylinder. Specify vector. Reverse direction. The diameter of this cylinder is 60. Its height only needs to be able to completely intersect with the bottom cylinder. We can roughly estimate that this paragraph is 100. The height of the 64 cylinder is about 25. Therefore, it takes about 75% for this section to intersect completely. 75, enter. Let's preview. 75 is feasible. Boolean. Unite. Select 64 cylinder. Application. We go on to draw the disc. The shape of the disc consists of 4 R80 arcs. Click. Select the top surface of the cylinder. OK. Click on the line L. Draw horizontal and vertical reference lines. Set to convert to reference. There is a width size of 76 here, so we can click on Offset Curve. Switch Single Curve. Select the numeric reference line. Click on Symmetric Offset. The distance is 76 to 2. Press Enter. Application. Select the horizontal reference line again. OK. Click on Circle O. Select any position in the drawing area and draw a full circle with a diameter of 160. As you can see from the picture, the center of the circle is on the horizontal axis. Select the center of the circle. Select the horizontal axis. Click Point on Curve. Select both the full circle and the line. Set tangency constraints. Click on Quick Extend. Click on Quick Trim. Click on Array Curve. Select the arc. The layout is circular. Click on Specify Point. Select the origin of the coordinate system. Count is filled in at 4. Pitch distance is filled in at 360/4. R28. Edge blend. Click on Fillet Weld. The radius is 18. Press Enter. Hold down the middle mouse button and drag. Click on Finish. Click on Extrude. Select the sketch. Note that its stretching direction should be 1 mm downward from the top surface. Click on Reverse Direction. The starting distance should be 1, and the thickness is 1.7. The end distance should be 1 plus 1.7. Boolean. None. Click on OK. Click on Pattern Feature. Select the disc. Choose Linear for layout. Click on Specify Vector. Select up and down direction. Count is filled in at 12. Pitch distance is filled in at 4.5. Click on Reverse Direction. OK. In this lesson, we have completed the task of modeling the cylinder block of an engine in Part 1. Have you learned? Please answer the following questions. This is the end of this lesson. Thank you.